Computer-based technologies are everywhere. Our modern society couldn't function for 5 minutes without the aid of countless computers that take care of everything from your morning coffee to managing the nation's power grid. One such technology we've come to rely on is the Global Positioning System, or GPS. In our video, we'll talk about its origin, how it works, its various uses and issues, and where GPS is headed in the future.
Since the beginning of time, mankind has been trying to find a dependable way to know where they are going from where they are, and then to find a way to get back again. A seaman could follow the coastline so they wouldn't get lost, and when the coastline was no longer visible, they could chart their course using the position of the stars. Fast forward to October 1957, when researchers at the Massachusetts Institute of Technology discovered the orbit of the Russian satellite Sputnik, which means traveling companion or satellite, increased as it approached the Earth and decreased as it left. Thus it was discovered that distinct positions on the ground could be determined by using radio signals coming from a satellite. This discovery was undeniably the launch of the GPS system. In 1973, the Pentagon designed and built the first Global Positioning System, or GPS. Today, the system is maintained and operated by the U.S. Department of Defense.
The Department of Defense operates a fleet of at least 24 GPS satellites that orbit the Earth at an altitude of about 20,000 kilometers. Their orbits are planned so that at least 4 of the satellites are in view from virtually any point on the Earth's surface. Your two-dimensional location can be calculated with only 3 satellites in view, but it takes 4 to achieve your 3D location. The satellites transmit radio waves, which are picked up by various types of receivers on the Earth's surface. In a process called triangulation, a receiver uses its distance from each of the satellites to calculate the receiver's exact location on the Earth's surface.
We use GPS very widely in our daily lives, and as technology advances, this GPS technology becomes more widely implemented. Our current usage of GPS is divided into 2 categories, civilian and military. With civilian use, we have 2 subcategories. We either use it commercially or personally. The civilian applications that use GPS include navigation, geotagging and geocaching, self-tours, map making, cellular telephony, location tracking for disaster relief or emergency services, tracking of people, vehicles, or animals, surveying, robotics, fleet tracking, tectonic tracking, and telematics. Military applications include weapon guidance, navigation, search and rescue, reconnaissance, and tracking of forces.
Have you ever loaned money to a friend? Then when it was time to pay up, wondered where they disappeared to? Well, for years, finance companies have been wondering the same thing. Don't worry, the stress of finding that elusive customer is no longer a hurdle. GPS tracking's in town. Our banker friend here just remembered that this vehicle is equipped with a state-of-the-art GPS tracking device. These nifty little devices, with the help of GPS guidance and cellular technology, can locate the vehicle and send its exact location back to your computer monitor in seconds. Now that's what I call showing me the money.
The first phone to have GPS was the Escape from Benetton. Smartphone uses of GPS today extend beyond the standard driving directions. Of course, GPS-enabled smartphones can guide to points of interest and alert to construction and traffic conditions. However, there are applications which can help the user work out, locate family members, and more. Cardio and Allsmart are applications which display valuable information while working out. In addition to mapping a course, counting calories burnt, showing distance traveled, and displaying the user's coordinates, these apps can also record each session into intervals and then allow the user to run against previous recorded sessions to track improvement. Cardio Trainer can upload these stats to Facebook, compare calories burnt to food, and much more. There are plenty of other smartphone applications that benefit from GPS. The fact that smartphones have assisted GPS make them work even better. Assisted GPS in smartphones is the process of the smartphone using a Wi-Fi connection or nearby cellular tower to give an approximate location for the GPS to more easily acquire position. This means as long as the phone is near a Wi-Fi spot or cellular tower, its GPS will find the location faster through less than ideal conditions, like a thunderstorm, using less power.
Yes, GPS is one of man's greatest technological achievements, but it's not perfect. You can lose your signal when you really need it. Using it while driving is pretty dangerous. The software is never up to date.
Arriving at McDonald's on Lyft.
What? Rely too heavily on it, and you might miss out on the obvious. Great, the nearest Home Depot is 40 miles away. And if you're concerned about privacy, assume that your GPS will leave an electronic breadcrumb trail. Bottoms up playhouse? You might not be aware, but your digital camera probably has GPS. Your Facebook stalker might find out where you live. As with all technology, have a backup plan. Carry an atlas. Pay attention to your surroundings. Figure out your device's privacy settings. Always use your good old common sense.
The future uses of GPS technologies are bound to go in directions far beyond what one can imagine today. Some industries where research and development are taking place are aviation and agriculture. The Federal Aviation Administration, or FAA, is changing the nation's air traffic control system from one that relies on radar technology to a system that uses precise location data from the global satellite network. In addition to the current civilian service provided by GPS, the United States is committed to implementing a second and a third civil signal on GPS satellites. The first satellite with these additional signals was launched in 2005. The new signals will enhance both the quality and efficiency of agricultural operations in the future. NASA is pursuing how GPS, along with seismic data, can be used to increase the reliability of global tsunami warning systems. The U.S. Air Force is in the process of deploying new satellites to replace older ones, and this replacement includes new capabilities to boost accuracy, allowing civilians to realize the same precision as the military. And finally, there is a flourishing commercial application and device market with some interesting ideas how the GPS technology can be used.